Welcome back with your physics teacher, me, Mr. Fernando, and in the last video you should have been able to see how we calculate the area under the curve from a velocity time graph to give us the displacement during each of the time intervals that the motion is changing for our friend, Sonic. But in this video I'm going to be showing you how we can get the position versus time graph. So let's try to organize this into a nice way to remember. So during the 4 to 8 second portion of the motion, it covered a distance of 56 meters. And during the 0 to 4 second portion of the motion, it covered a distance of 20 meters. So let me write this down to help us remember it easier. Like we have been doing before, one way we can go from one graph to the other one is to make sure that we line them up nicely below each other such that the time axis can be lined up perfectly. So let's see what that looks like in this case. And we are trying to make a position versus time graph, so this is going to have d with units of meters. And we wanted to break this down into two intervals. My bad. We were interested in 0 to 4 seconds. So this is the 4 second mark. And then from 4 seconds to 8 seconds. So this would be the 8 second mark. Well, what kind of motion is the Sonic undergoing in the first place? Speeding up. And speeding up while covering a total distance of 56 meters. So then we have to think back, how do we represent speeding up for a position time graph? It was a parabolic curve, right? And for the second part, from 4 to 8 seconds, it is also speeding up. And in this case, it covers a distance of 56 meters. How do we represent speeding up in a position time graph? It's going to be a parabolic curve as well. But if you want to see how we can distinguish between the parabolic curves, check out my other video, and in that case we go look at the tangents and the trends as it changes with time. Now there's a big issue with position time graphs. We don't know where Sonic begins. We don't have the initial position. This is the problem. So this is just telling us the initial velocity for a velocity time graph, but it also tells you how much distance is traveled. Nowhere does it tell you where the object begins. This means that you and your friend are going to have very different graphs for the initial position. Now, to make things a lot easier, assume for most cases that your starting position is going to be at the 0 point. In other words, if you think back to where we used to draw the tree, remember a good old friend, the cheetah? Now it got replaced by Sonic. Sonic's a little bit more exciting, maybe, right? But Sonic is a panther, a puma, hedgehog. That's strange. Anyways, here we have a position time graph. And drawing it from a VT graph, you have to assume the position will start at the origin. And since we know that the velocity, and more specifically the sign of velocity, if it's a positive velocity, it tells you that the direction is moving in the positive direction. How do we represent it with a tree? It means it's moving to the right. Or another way of thinking about it is towards the east values, or the positive direction. And how much distance does it cover? 20 meters. So during the first 4 seconds, Sonic is able to cover 20 meters heading to the right in the positive direction from the origin. Now, why did we draw this curve and not its alternative, which would have been this parabolic curve, is by considering the tangents. So I'm going to use the marker as tangent. Notice I'm thinking about the red one. It starts off slow, or in other words, zero slow, and the steepness is getting larger and larger, which represents speeding up. But if you had drawn the other curve, it starts off really high for steepness, and then as it goes with time, it gets less steep, so that would be showing slowing down. That's the reason why the green line would be wrong in this case. And during the next 4 seconds of time interval, we cover a distance of 56 meters. Now, this is where it gets tricky. This is the 56 meter point. Most students will draw from 20 to 56 and think that we got it correct. But remember, displacement, which is what we calculate here, is the change in position from where you left off. So we left off at the 20 point. From this 20 meter point, the change in position has been another 56 meters. So that's going to be 20 plus 56. So it should be at the 76 meter point. All right, I hope you got that point. You might want to rewatch it again. And during this next 4 seconds of time interval, Sonic was also speeding up, but with a slightly less acceleration, so that means that the steepness of the curve should not be as curvy. All right, I know that's really difficult to draw, but I think you should get the main idea of the distance travel, and in this case, how do you quickly check if it's speeding up? Your tangents drawn in the position time graph are getting steeper and steeper, which means speeding up. So that's how you draw your position time graph, and the next video I'm going to show you some more difficult examples, and please ask your questions in the comment below, and please hit like and subscribe, and then we keep learning physics together.